Finally, in part 4, what we want to do is compare, contrast the results of part 1 through 3. So, first of all, let's look at the results we got for part 1, 2, and 3. Part 1, part 2, and part 3. In part 1, we had 1.7 stars as the point estimate, plus or minus a margin of error of 0.07. In part 2, we had 1.7 stars as the point estimate, plus or minus a margin of error now of a little bit bigger, 0.278 stars. And then part 3, we had 1.7 plus or minus 0.52 stars. Certainly bigger. In number 1, the standard deviation was 0.2. That's how much variability was in the original distribution of X, which is just people putting in their ratings for this person. Right? 1 star on average, 2, 3, 5, 2, 2, 2. How were the values? How were they spread out? How were they dispersed? Were they consistent? Were they very volatile? Is it easy or hard to predict what somebody was going to give this person as a rating? Well, in number 1, standard deviation is 0.2. In number 2, it was 0.8. And in number 3, it was 1.5. So in which case was it easiest to predict what rating he's going to get? The answer is number 1. Smallest amount of variability. The bigger the standard deviation is, the more variability there is. Therefore, the smaller the standard deviation is, the less variability there is. And this variability, now we're just translating into the distribution of the sample means, which is we get that variability, the standard error, by taking the population standard deviation, 0.2 in number 1, 0.8 in number 2, 1.5 in number 3, and we're dividing that by the square root of the sample size each time. And that got us the margin of error. So the margin of error, holding other things the same, other quantities the same, is getting bigger when the standard deviation goes up, because there's more variability in the data set, right? So the idea of estimating, it's going to be harder to estimate something intuitively, right? Think about it. It's harder to estimate what the truth is if the thing we're using to estimate the truth is more variable. So let's look at the confidence intervals that we ended up getting. I'm gonna start cheating just a little tiny bit on rounding. I'm gonna put 1.6 here, just so it's easier to deal with. 1.6 is the lower bound, and then the upper bound is, how about 1.8? And then in the second one, I'm going to continue cheating. 1.4 is the lower bound, Greek letter mu, which represents the true mean. And the upper bound I'm going to put as 2.0. And then the last one, 1.2 is the lower bound, and the upper bound is 2.3. So number 1, we have this interval. Number 2, we have this interval. Number 3, we have this interval. So what is the relationship here? Well, the greater the variability in the original data, the wider the interval has to be.